Chapter 2-1, completing the square. Completing the square is used for the following things. 1, finding the vertex of a parabola. 2, factoring completely. And 3, finding the x-intercepts. Completing the square is a wonderful, wonderful, very useful tool. But it is the absolute devil whenever it comes to doing algebra. Okay, some of you will hate it. When can you use this? You can only use this method when your degree is level 2, meaning the highest exponent on your variable is 2. Degree means highest exponent. Possible types of solutions that you may have. You may have a rational number, meaning any number written as a fraction. You can have an irrational, meaning the square root, or pi. You can have an imaginary, meaning it's just plus or minus 2i, or plus or minus bi. And you can have a complex number, meaning it's a plus or minus 2i. Complex means it has a real number part plus an imaginary part to it. Okay? Now, leading coefficient. Leading coefficient is the number that is attached in front of the x squared term. Okay? Whenever I refer to leading coefficient, I'm talking about the number attached to the x squared term. Moving right along, steps to completing the square. Step 1, replace f of x or y with the number 0. Why am I asking you that? Because generally speaking, you guys do so much better when you're not dealing with more than one variable. Okay? So by putting 0 in for y, what you're essentially doing is finding the x-intercepts, which means you're actually just putting it in the standard form. Okay? Step 2, take the constant term over to the other side. What's a constant term? It's the number without the variable. Okay? Step 3, the leading coefficient must be 1. What's the leading coefficient again? It is the number in front of the variable that is squared, okay, in front of the x squared term. That leading coefficient must be 1. If it is not 1, what we have to do is make it 1 by factoring out your leading coefficient. Not a GCF, but your leading coefficient. Do we all understand that? Okay? Next, take the coefficient of the x term and divide it by 2. Step 5, square this number and add it to both sides. Now, if you're adding it to both sides and then you pulled out your leading coefficient, you have to also multiply that by your leading coefficient. And we'll talk about that here in a little bit. And then write the x side of the equation to be x plus a number quantity squared. Now, the quadratic function can be shown in 2 different ways. It can be shown as ax squared plus bx plus c. This is standard. This is what you guys are used to. Okay? Whenever you see something like that, you immediately want to try to factor into 2 binomials, right? If you can factor into 2 binomials, then you're doing great. If you can't factor into 2 binomials, then it's going to suck. You're going to have to complete the square. Okay? Standard form is what we really, really, really like. And the reason why we like standard form is because we can get the most for our bang out of this. Okay? What do I mean about that? What I mean about that is I can get a lot of information from standard form. I know A tells me that it stretches or reflects or shrinks. I know that the H is going to be the left and the right. And I know that the K is going to be the up or the down. And if I put the up and the down, the left and the right together, that gives me my vertex. That vertex is going to be the point HK. You with me? Okay? Now, the vertex is going to be the lowest or the highest point on the parabola. Meaning it's the point on the graph where the direction is going to change from increasing to decreasing. Okay? Also known as the max and min values. Now, talk to me. What does this equation, y equals 2 times x plus 3 quantity squared minus 7, mean to you currently right now?
Standard form.
It's standard form, but what does it mean? What do you get out of it? Alex? Where the parabola is placed in the graph. Tell me. What does it mean? It's stretched by 2. It's left 3 and it's down 7. Well, guess what? From the left 3 and the down 7, I now can get something new out of that. I can say what my vertex is going to be. So my vertex, if I'm going to the left 3 units, what does that mean on the x-axis? -3. If I'm going down on the y-axis 7 units, what does that mean?
-7.
-7, which means now I have this graph that looks like that, right? I know, wasn't that kind of nasty? But it still worked, right? Okay, do we understand that? Yes or no? Does that make sense? Okay? Well, let's talk about this number 2. What do I know about this? It's a stretch by what? What else? We missed something right away. It's reflected over the x. And what's the negative 2 do? It's going to the right 2? Up 5, which tells me I can now get my vertex out of this thing. If I'm going to the right 2 units, that means, and that positive 2 for x. If I'm going up 5 units on the y, that means positive 5. And I can graph this thing. Now is it opening up or down? It's opening down. Pretend that landed there. Okay, do we all understand that, yes or no? I get a lot of information out of standard form. If it was given to you in the ax squared plus bx plus c, could you get any of that out of there? No, you couldn't get a picture on your head. You would have to immediately grab the graphing calculator. So now let's talk about this. If I were to give you the x squared minus 8x plus 16, instinctively you would want to do what? I'm sorry? Factor into 2 binomials. So if I put this into 2 binomials, how do I split up x squared evenly? X and x. And I need to have a positive 16, which means I have plus plus or minus minus. How do I know which one to take?
Minus because it's minus 8.
No. It's minus there because it's in the middle term. So I'm going to have minus minus. Factors of 16 to add to give you negative 8. 4 and 4. Now, what I want you to notice is that I have how many of those? 2. So x minus 4 quantity squared is what that thing is equal to. I need your brain to not do any work and go from the x squared minus 8x plus 16 all the way to the x minus 4 quantity squared without thinking. Well, let me show you the trick.
That was a trick.
No, the trick is I take this lovely little term, and I take that 8 and I divide it by 2, and it gives me 4.
Where'd that come from?
Oh, you know.
Where did that come from?
Where'd the 2?
Take the coefficient of the x term and divide it by 2.
I'm asking why.
Because we're going to complete the square.
What if the x is odd?
What if it's an odd number?
Yeah.
That is a nasty fraction. It still works. Okay? What this means is I take that middle sign, put my 8 divided by 2, and that's what it gets every time. So let's do the trick again. Before I do the trick, let's first factor this into 2 binomials like you already know to do. Let's do it. Plus and plus. Factors 144. 12 and 12, does that give me 24? Yes, it does. So I have x plus 12 upon b squared. Well, if I take my middle term and divide that by 2, what does that give me? 12. Isn't that exactly what I needed there? Yes. So now we're not going to factor this next one. We're going to go straight to our trick. So I'm going to take 18 and do what to it?
Divided by 2.
And that gives me 9, and I take this sign, so I'm going to have x minus 9 squared.
You always take the sign from that number.
Yep. From the middle term.
Gets.
Nope. Okay? This is review from last year, stuff that you should automatically remember. Now, let's actually do the hard part. Now, what we want to do is we want to find the vertex and the translation of the parabola by completing the square. Meaning I want this in standard form, y equals a times x minus h quantity squared plus k. Correct? Well, that's what I want. Y equals a times x minus h squared plus 6a. That's what I'm looking for here. So step 1, on the steps that we just had previously, what step 1 say to do?
Replace f of x to y.
Replace f of x with 0. So 0 is equal to x squared minus 8x minus 1. Next, what do I do?
Take constant term over to the other side.
Take the constant term over the other side. So what do I do? 1 is equal to x squared minus 8x. Next. The leading coefficient must be 1. Well, is my leading coefficient 1 here?
Yes.
Yes, so I'm good. So next step.
Take the coefficient of the x term and divide it by 2.
So I need to take my coefficient of my x term, which is right here, and I need to take 8 and divide it by 2 to give me 4. Well, what am I going to do with that 4? What's it say to do?
Square this number and add it to both sides. Be sure you have multiplied by the number you factored out.
Did I factor anything out? No. So what I'm going to do is I'm going to take 1 plus 4 squared is equal to x squared minus 8x plus 4 squared. And I'm actually going to write these in different colors so that you guys can see it. You can generally see that better when I'm writing. What I did here is I'm going to add 4 squared to my right-hand side. I have to keep my scale balanced. So I have to do on one side what I did to the other. Do you understand that? The golden rule of algebra. Okay, so if I'm going to drop 4 squared, which is 16 on my left, I need to drop it to 16 on my right. Do we understand that? So now 4 squared is going to be 16. Now what do these 3 terms turn into on the right? It's a binomial squared, and do I need to think about that, or can I just take that middle term and divide it by 2? So that's going to give me the x minus the 4 squared over here, and that gives me 17 on the left. Do we see it?
Yes. Yeah, she's shorter eyes.
Now what do I do?
So the 4-digit numbers. You rewrite the x side.
We'll take that 17 back over. Right? And replace that with f of x is equal to x minus 4 squared minus 17. What I want you to understand is that this, what I boxed in, is exactly the same as what we started with up here. Now, how do I find the vertex? Well, the vertex is h and k. So you tell me, what does this minus 4 do to the equation? It moves it to the right 4 units, and what does the minus 17 do? Moves it down 17 units, so what's my vertex going to be? Well, right means it's positive, and down means it's going to be negative. Do we understand the vertex? Yes or no?
Do we have to write down the R4?
I'd really like to hear that. You do not have to write down the R4 and D17, but I strongly suggest doing that because your brain instinctively is going to say, well, that's moving it to the right, so what's it doing vertex-wise? If yours doesn't, I'm okay with that. Okay, do we get this part right here?
I'll do the next one.
Okay, well, we're not done with this problem because now I found my standard form. Now I want to find my x-intercept. Well, by definition of an x-intercept, can anybody tell me what that actually is? It's the point on the graph where it crosses the x-axis. So if it's crossing the x-axis, what does that imply?
Oh.
That I have an x-intercept, but what does that mean to be an x-intercept? That you're popular? What this means is y value has to be what? If I'm crossing the x-axis, meaning it's going across. If I hold out my arms, it's crossing my arms. What does the y value have to be every time? 0, correct? Because it's crossing the x-axis, which means y has to be 0, which means this thing is 0 is equal to x minus 4 squared minus 17. I'm going to solve this thing for x. So how would you go about solving this thing for x? You'd add 17. Then what would you do? Take the square root of both sides. Now, when you take the square root, you're implying that there can be a positive or a negative value, right? So you have to add plus or minus there. Now, what are you doing? Add 4 to both sides. So I have 4 plus or minus the square root of 17 is equal to x. I have one issue. Because an x-intercept is a point on a graph, I want an ordered pair, don't I? Because that's what makes it a point. So my first ordered pair is going to be 4 plus the square root of 17, comma 0. And my next one's going to be 4 minus the square root of 17, comma 0. These are my x-intercepts. Now, when in doubt, what do we do?
Cry.
Graph it, right? Right? Yeah. When in doubt, graph it, right? So here we go. We are going to graph it. I want a new document, I want a graph, and I want to graph the original function that was given. So what was the original function? X squared minus 8x minus 1. And hit enter. This is my graph. Well, my vertex is all the way down here. Does that make sense according to what we got? It does make sense according to what I got, because our vertex that we came up with was what?
4, -17.
It was going to be right 4 and down 17. So how do I calculate that? Hit menu, analyze graph, and what do you think I want? Why minimum? Because it is the minimum value of the graph. So I go to the left of the valley and click, go to the right of the valley and click, and check it out. Is that the point that we got for our vertex? Are we right so far? What does that tell you about our standard form that we got previously? That we did our work correctly. Now what we want to know is, did we find our x-intercepts correctly? So my x-intercepts are going to be clear up here on my x-axis, right? And I need to find my x-intercept. So I need to hit menu, analyze graph, and this time I want a 0, because the 0 is another name for an x-intercept. Do we all understand that? So I'm going to go to the left, and then to the right, and there's 1, 0. I'm going to do that process again. Go to the left and go to the right, and there's my values. Now you can do this 2 different ways.
Oh, that's what.
You can hit your scratch pad and you can say, well, what was 4 plus the square root of 17 decimal-wise? Hmm. 4 plus the square root of 17. Enter. Is that right? Yeah. Arrow up. Grab it down here again. Backspace that out, put a minus sign, and hit it. Are those the values that I got? Backspace? I arrowed up and hit enter after it's highlighted. Okay. And I can clearly see that my values that I got are absolutely correct. Do we understand that? Yes or no?
Which version do you want to change? Like that or like that?
I never want them in decimal version. I always want them in radical form, because radical form is going to be your best way whenever it comes to multiple choice on a test or something like that. That's what you're going to do.
That's the
Okay?
4 plus the square root.
Yep, that's 4 plus the square root of 17 and 4 minus the square root of 17. Okay, let's do this again now. This time, I'm going to have some ugliness going on, aren't I? Why am I going to have some ugliness going on? Because my leading coefficient is not 1, is it? So step 1, what do I need to do here?
Subtract.
I'm on the next slide.
Subtract 7.
Okay, Jet and Morgan, pay attention.
I just
I know. Moving on. Now, f of x is what value? What do I need f of x to turn into? 0. 0. So 0 is equal to 2x squared plus 8x plus 7. Now what? Subtract the 7. So minus 7 is equal to 2x squared plus 8x. What's the next thing I need to check? No, sir. That leading coefficient must be what? That leading coefficient needs to be 1. Can I divide each term by 2? No, because if I divide each term by 2, I'm losing my a value when I do my standard form, aren't I? Because I'm eliminating it. Then I don't know if it's stretched or reflected or any of that jazz, right? I need that to stay. So the way that stays is by, instead of dividing by 2, I'm going to factor out a 2. So if I factor out a 2 on the right-hand side, what is 2x squared whenever I pull it out of 2? X squared, and what's left after 8x? Okay, so now I've pulled out my lovely little a value. Do we all understand that that 2 is going to be my a value? So what do we immediately know about this function? It's stretched by a factor of 2. So now what do I need to do? Do the steps change? No. So what's the next thing I need to do? Take that middle term, which is going to be that 4, and I need to divide that by 2 to give me 2. Now what do? I need to square that value and add it to both sides. But I have a problem because I have parentheses on the right-hand side, don't I? Which means I am going to add that inside the parentheses. So can you tell me how much I actually added on the right-hand side? Did I add just 2 squared? What would you do on that 2 on the outside, that a value of 2? You distribute that. So what you're telling me is I actually added not just a 2 squared, but a 2 times a 2 squared. Correct? Do we see that? Yes or no? Okay? So on my left-hand side, I need to bring in there -2 or -7 plus 2 times 2 squared. Then it's equivalent.
Basically, whenever
That attitude more good.
you just split it in half, and then you can just add it, whatever's on the outside of the parentheses, you multiply it by that, put it on the other side.
Every time.
How do you get the +2 on
Because whatever you add, are we all listening? Time out. Alex said it perfectly.
Tell me to say it again.
Whatever you add on the inside of the parentheses, you add that on the left-hand side too, but you have to multiply it by the junk that's in the parentheses.
Why does that 4 stay?
Because that 4 was from the original. Okay? So now, what is 2 squared? 4. So this is -7 plus 2 times a 4 is equal to 2 times an x squared plus a 4x plus a 4. Now you need to use your trick, because those 3 terms need to turn into what?
X
Find out
plus
this.
2 squared.
X plus 2 squared. So on my left, I have -7 plus 8 is equal to 2 times an x plus 2 quantity squared. I just wrote what you said.
I said it slower.
What is -7 plus 8?
1.
Is it in standard form yet?
No. You have to add it.
Bring that 1 over the other side. And now what does 0 turn into? Y or function notation f of x. There's my function, and now my question to you is what is my vertex? Well, what does this +2 on the inside mean? Left 2, what's the -1 mean? Down 1, so my vertex turns into what? Come again? -2, -1. Do we all see that, yes or no? So I have my vertex, now what am I going to look for next? Well, you see the problem right below it.
X.
Then I want my x-intercepts. So how do I find my x-intercepts?
Graph.
You can graph it, however, I'm not going to allow you to graph it on your test. You're going to actually check it. What I want you to do is what? Solve for x, because by definition of an x-intercept, y has to be 0, and I have to solve for x at this point. So how do I go about doing that? I have 3 minutes, okay. I need to add, thank you, John, add the 1, and then do what? Divide by 2 on both sides. So x plus 2 quantity squared is equal to 1/2.
X square root.
Plus 2
Doesn't matter.
Square root both sides.
So take the square root of both sides. I'm going to take the square root of the top and the bottom of each one of those fractions, that fraction, right? What's the square root of 1? 1. What's the square root of 2? A nasty number. So I have x plus 2 is equal to plus or minus 1 over the square root of 2. Now let's see if we can jog your memory. How do we rationalize the denominator? Now if I have 1 over the square root of 2, how many 2's must I have on the inside of the radical to pull 1 on the outside?
1.
I have the square root, which means I have to have a perfect square. So I need 2. If I had the cube root, I'd have to have 3. If I had the 5th root, I'd have to have 5. If I had the 10th root, I'd have to have 10. We all get this. So I need to have 1 more 2 inside there. So I multiply by what I need on the top and the bottom. And this gives you the square root of 2 over the square root of 4. And what is the square root of 4? What is it? 2. So when you rationalize, this and this are equivalent. We do not use this one.
Can you go back, please?
Hold that thought. Okay, so we have x plus 2 equals plus or minus the square root of 2 over 2. X is equal to negative 2 plus or minus the square root of 2 over 2. And we now have our x-intercept. I'm running out of time. I have minutes, like probably not even a minute. Negative 2 plus the square root of 2 over 2, comma 0. And negative 2 minus the square root of 2 over 2, comma 0. There's your x-intercepts. Now I want to draw your attention to the worksheet from tonight. Okay? Problems 1 through 8 on the front, they are all in standard form. So all you people have to do is do up, down, left, right, find the vertex, and match the graph accordingly. Did you all understand what I just said? On the back, problems 1 through 18. If you can factor the two binomials, factor the two binomials to put it in standard form. Some of them are already in standard form. Others of them you're going to have to complete the square. On problem 17, distribute that negative 3/5 and then go from there. Have a great day with the two problems 1 through 18. See you guys. I'm ready to stop.